And then the last thing we tried today, damn, we did a lot of things today. Proud of myself. Inject some positivity into all these failures. And then the last thing we did was, what was the last thing we did? Hello everyone, today we're going to be adding multi-threading to the recurrent neural network library that we built from scratch. We're just going to have it such that when it's training on another thread. And that'll hopefully free up the main thread so that it can do other stuff and run a game without it struggling. All we're just going to be doing is whenever we come down to the train function, rather than it using the main thread for training, we're just going to create a new thread, have the train happen on that new thread. So just forward pass back prop on that new thread. And then when it's done, it then synchronizes the matrix with the current thread. What I'm just trying to figure out is, so we do forward pass and then we do a back prop. When we do the back prop, we are updating the weights. When we update the weights, if we do a multi-threading, it's going to be updating on a new thread and it's going to have nothing to do with the current thread that we're currently working on. When and how do we kind of make sure that the weights are the same? So what we're doing is we're creating our new thread. We're basically just creating a copy of our old neural network library, and we're specifying that this one will pretty much only run train, just the train function. And so we create our parameters. Unfortunately, when you are creating a thread and you're trying to communicate with that thread through a channel, the only thing you could really do is use an array, or at least a flat table, and this is a dictionary here, and so we can't pass this dictionary through. So what I tried doing was I tried looping over that dictionary, turned it into an array, and then passed that array to the thread. Now in this thread, I then have to read that. Oh, hold up. Even that's giving us an error. It's saying that we can't pass it through because it's not actually an array. And that makes sense because if we take a look at it here, it's not a flat table because we have our bias table, how that's implemented. I'm just trying to think, should we just give up on this multi-threading thing? It's not more of a pain than I thought it was going to be. Let's see if there are any other ways we can implement multi-threading. Otherwise, I think this is, after tonight, I'm just going to give up on multi-threading. It's not working. That's what happens, right? Sometimes you experiment, things don't work the way you want them to, and there's not really much you can do. Not really much you can do about that. Like, I'm giving up on this multi-threading. It's just way too convoluted. For no reason. It doesn't have to be this complicated, but it's way too convoluted, and so there are other tricks that we can probably use, and I might try to implement those instead. Okay, so let me restart and let me redo my intro for the devlog. Hello everyone, today this is too funny. We started late. It's a disaster. I'm giving up on multi-threading. The wheels have officially come off. Hello everyone, today we're going to be adding some final optimizations to our recurrent neural network before we move on. One thing we're going to be adding is something called truncate for back prop. And so essentially what that means is rather than doing back prop for all of the time steps, what we're going to be doing is we're just going to be truncating it and only doing back prop for a few time steps. That's number one. Is it actually going to learn? I don't know. I don't really care. But so that's one thing we want to take a look at. Another thing we want to take a look at is breaking up our inputs. And so, for example, the first sequences that we can train the network on would just be the first 2 or first 3 letters of the words. That's the first batch that we train it on. And then we can train it on the next 3 or 4 letters within the word. So those would be 2 different batches. So hopefully with the truncated back prop, there are fewer multiplications that our network needs to do during the training. Hopefully that will speed it up and that will get us the performance that we're looking for. So in order to do the back prop truncate, I think it's quite simple. All we just need is just to add a parameter here. So let me actually set it in here. Truncate, let's do like 3. What? What the hell how the hell does this work? Why are they starting from t-1, I guess is my question. Okay. I'm just going to make a guess because I don't know what the hell this means. Anyways, point is, we're going to be going through, rather than going through and doing back prop for all the time steps that we specified, we're going to be going through and going to be doing back prop for only the amount that we specified within our truncate parameter. We've gained like an additional frame. We were running at like 3 frames per second before. We're now running at 4 frames per second. So yeah, we've gained an additional frame, but my problem is our loss is increasing. So we've done something completely wrong. What have we done? And these aren't words that it's forming. Oh, hold up. Okay, I think I may see where things might be going wrong. Now nothing makes sense to me. The loss is just kind of bouncing around. So I don't know if this is actually learning anything, but what we can see is so far it's learned S and E at the end of the word because. That's great. Also, we're getting like 4 frames per second, which is quite small, but it's greater than 3 frames per second. People, it's also learned LE at the end of the word people, so I guess that's good. I don't think our truncate thing is actually going to work. In here, when we're training our network to say hello, we're feeding it a letter for every time step, so H, E, L, and then L, and what we're expecting is it's going to output letters corresponding to the word hello. At every one of these time steps, what it does is that it spits out what it thinks is the output, and then we tell it no, or we give it the correct output, and so it's able to take that and it's able to learn. Now, if we truncate it, basically what we've done is that we're only, for example, if in the word hello, there are 4 time steps here. If we truncate it, which is what we've done in this case here, and we only give it the last 2 answers, it's not going to know what these 2 answers are, and I don't think it's not going to care. And so I think that's the problem that we're running into, and that's why it's not able to train on. That's why it's not able to train on these train and learn these words. And so I think this truncate is mainly for if you have like a time series, or if you have other functions that you want to graph out and you want to learn the pattern within that. But I think for words, I don't think it actually works as well as we'd hope. That's that. But I mean, we gained an additional frame. So clearly it works. It's just, unfortunately, it just doesn't work for our, it works and it optimizes our code, but unfortunately it just won't learn for our use case. And so this was a failed experiment, but at least we tried something. The last thing we're going to do is we're just going to, I forget exactly what it's called, but so for example, the word people, there are 6 characters in this word, and so you can batch it such that you're training it on the first 3 letters, and then the next instance you're training it on the last 3 letters, and so that will hopefully speed up the training because there are fewer time steps you have to train it on. But essentially what we're going to do is we're going to loop over the input and the target words arrays. We're going to break them down into different batches. That's number 1. Let's say, for example, we set our batch size to, let's say we're setting it to 3, so meaning we're feeding or we're training it on 3 letters at a time. Let's do this manually first. So hopefully this works and this won't give us any issues, but we'll print it out and we'll see. We'll print it out and we'll make sure everything works as we want. What these loops will do here is that they will go through and they will batch our words into batches with just three letters in them. So let's reduce the number of words that we have. Let's go ahead and let's print that. Let's see if we actually get what it is we were expecting. So we have 27. Okay, that looks. Hold up. Oh no. This is all the words. This is the specific word that we're on. This one only has 1 letter, and then it moves on to the next word. That word has 1 letter. Then it moves on to the next word. That word has 1 letter. So we've messed something up, which I'm not surprised. Why did we mess up? Well, we messed up because for every word that we start, we completely obliterate the array that's in that word, and so that's why. And so eventually, what you end up with is just 1 letter. So let me just move all of these out here. Hopefully that works. Let's test that out. Let's try that out. Let's see what happens. What do we get this time? So once again, this is table 1. These are all the words that we're currently working on. That's the current word that we're on. So for example, the word there, because we're truncating it into 3, we should only have 3 characters in here. So that's 1 character, 1 letter, 2 letters, and 3 letters. And then just quickly double checking, the 20th letter in our alphabet should be a T. Yeah, okay. That's all I'm going to double check, just so we can kind of move through this really quickly. So that works. So theoretically, what you do is you would take the first batch, feed it into the network. Once the error gets to a point where it's low enough, then you take the second batch and then you feed it into the network and you have it trained on that second batch. So first batch would just be the first 3 letters of the word. Second batch would be the last 3 letters of the word, and then we'll train through that as well. And so that's how you would do it. But I guess for us, what we're just going to do is manually do it. Let's say like 1,000 epochs for each, so 1,000 training instances for each sequence that we feed it. That makes sense, logically. But I know that I think differently than my computer. So let's see what the computer has to say about our code here. So it's trained on the first batch, trained well. It didn't necessarily train well on the second batch though. So let's maybe do 200 epochs. It's learned decently well that, you know, if we for the word there, again, we don't feed it this initial T, but it's learned that the next three letters in this word are HEI. For the word have, it's learned that the next three letters are HAVE. For the word another, it's learned that the next three letters are NOT. So it's learned that. Now that seems to be well. Again, our problem is when it then moves on to the second batch. When it moves on to the second batch, everything kind of just goes crazy. And it just completely unlearns everything it's learned before. Why does it do that? Why does it do that? I think the reason why it does that is because it no longer has the context that it gets from the outputs of the previous hidden layer, or the previous hidden layer calculation within the sequence. And so I think that's why it doesn't work as well as we'd hoped. How do you mitigate that? Do we just overlap sequences on top of each other and it's more of like a stride thing? Or that could work, maybe. Is there a way that we can preserve the hidden hidden layer values? But I think the biggest win here is look at our frame rate. I mean, it's not. I mean, okay. I think it's pretty good. Like 30 frames per second compared to like 3 frames per second we were getting before. That's good. That's really, really good. But again, that's just with our test here. If we test it with the training set that we were having problems with before, see what happens. I think I spoke too soon. But also, like, we are printing all these weights to the screen, so that's quite heavy. So a few things. Frame rate really isn't that amazing anymore. We're still stuck in like the single digits, like 4 frames per second. Okay. It did improve the performance of our network, and it's more it still is a little complicated and convoluted, because now I need to figure out how we merge things together. You know, in our hello example, the first 2 time steps, they come together and they produce this value for the hidden layer, and so that's what gives the network memory and context as to what letters it has seen before. But when we then batch it, we split everything up. So for example, you know, we train it on just the first 2 letters, and then we train it on the last 2 letters. That context and that hidden layer value is no longer there, and so then I have to find a way to like stitch everything together. Bottom line though is it even worth it? Doesn't look like it at all. We've gained like 1 frame. Okay, that's a little depressing. It's very, very depressing. I mean, that's just how it is. Like, you just experiment, you try things out. If it works, great. If it doesn't work, then, you know, it's at least you tried. And so, you know, like I said at the very beginning, for so we failed twice today. What a day. We tried to implement multi-threading. That failed for so many different reasons. It failed, and I also just kind of gave up because we spent way too much time on this. Initiating a new thread, passing all of our weights and our matrices and our parameters and everything to this new thread is just way too complex, and so it just wasn't worth it. We tried to set up something called truncate. So truncate means that rather than training the neural network on all of the time steps within your sequence, only train it on like a subset. In theory, it's supposed to help the network train faster. Problem that we found was because we are training it to output a word, it kind of does need to know all the letters that are in that word for it to output the word. Imagine trying to train the network to output the word hello. You're only telling it if the L and the O at the very end of the word hello is correct, but you're not telling it if, you know, the E and the first L are correct. The last thing we did was we went ahead and we tried to batch our words, you know, take the first 3 letters as one batch, the next 3 letters as another batch. It looked like it worked. When we actually took a look at the frame rate, it didn't really seem as if it was that much of an improvement. We were getting about 3 frames before, and then after we implemented that, we bumped up to 4 frames per second. There's also a whole bunch of other complications with the fact that now, you know, because you have 2 separate batches, you need to fill in the neural network's memory. After it trains on the first batch, what's the memory or what's the context it will use to train on the second batch to know that those words are connected together. Again, because we didn't really see a huge performance improvement, we're going to put a pin in that. I don't think it's worth exploring this much further. It was a cool experiment. We tried it. It doesn't really look like it's working. And so we are moving on. We're moving on. I can't do this anymore. We spent way too much time on this. This is just not working. Oh man, so disappointed. So disappointed. Everything just failed today. Oh well. It was a good learning experience. I'll say that. It was a good learning experience. And then the last thing we tried today, man, we did a lot of things today. Proud of myself. Inject some positivity into all these failures. And then the last thing we did was, what was the last thing we did? Batched sequential input, something like that. I don't know. Man, I don't even know if that's a thing. I just made up that word. Not that. Get out of here. We don't talk about you around here. It's not more of a pain than I thought it was going to be. Now nothing makes sense to me.